Hi everyone, my name is Aksa Benny. We as a team are here today to present our final project, which is a web search engine for our advanced computing course taught by Dr. Abdel Rahman Al Khatib. My teammates are Roxy Leonard Palmer, Rahul Mihani, and Sarajit Kaur. In this slide, we can see the structure of this presentation. We can see it starts with listing out the participation of each team members for this project. Then we will move along to the introduction, background study, general problems faced by common web search engines. After that, we will look into the methodologies that we are implementing along with an explanation of every feature. Then it will be the most interesting part of our presentation, which is going to be a live demonstration of our working project. Then we will see the future studies, the conclusion, and the materials that we have referred to make this project successful. Now let's look at the contributors for our project. Roxy have worked with the conversion of HTML to text files. He have also implemented the search functionality using Boyer-Moore algorithm. Rahul have implemented a web crawler and he have worked with indexing. Sarabjit has implemented edit distance and Java regex module, and I have worked on the spell checker and the sorting algorithm. Now my good friend Sarabjit is going to start with the introduction of our project.
Thanks, Aksa. I'm Sarabjit Kaur. Let me give the introduction of a web search engine. Basically, web search engine is a software system or a server that is designed to carry out the web searches for a given information. There are four basic functionalities which a web search engine should have. These are web crawling, to crawl from site to site, indexing, searching, and sorting. In our project, we have implemented these functionalities. Moving on to the next slide. Background study. Web search engine was invented in early 90s to overcome the increasing difficulty of locating information in growing data. First web search tool is Archie and first web search engine is W3 Catalog. Presently, there are many web search engines available in the market, namely Google, Bing, Yahoo, Baidu, Ask.com, DuckDuckGo, and many more. Google is the most popular among them with a market share of 92.49%. Moving on to the next slide. General problem. There are some general problems with the web search engine. The first one is reliability. Web search engine do not return 100% relevant data all the time. Search results are not always reliable because it is difficult to validate the search results from huge online data. Next one is low effectiveness in retrieving information, as obtaining the significant volume of information in a short period of time is very challenging. The last one is websites responsiveness. Web pages over the internet are changing dynamically every second, and it has a significant impact on the accuracy of search results. Moving on to the next slide. Our problem statement is how to apply concepts learned in class to build most efficient web search engine. And in our project, we were able to make web search engine by applying the various concepts learned in the class. Now, Roxy will take over the next slide.
Thanks, Arab. Hi, my name is Roxy Leonard Palma and I will take you through the methods used to build our project. We have used WebCrawler, that is an internet bot that systematically browses the World Wide Web. Then to index the URL, we have used HashMap. To convert the URLs to text, we have used JSON. Boyer-Moore algorithm was used to search for the number of occurrences of the word, to suggest alternative words when the result, or to check the spelling of the given word, we have used spell checker. When the result is found, the pages are then sorted in the descending order. Let's start with what a web crawler is. A web crawler, also known as a spider or search engine bot, downloads and indexes content from all over the internet. Here we take an input from the user which specifies the initial URL or the root URL to crawl. As it crawls, it will find all the hyperlinks that leads to other URLs, which are then added to the list of URLs to be crawled. Typical crawler performs a breadth-first search traversal. Consider the formation of URL page as a tree structure. Else, when a depth is defined, example, a depth of 0 would mean just going through the base URL. For our project, we are using a depth of 2, which can be changed based on the level of search we want to perform. Furthermore, we are optimizing our crawler so that only subdomain links are crawled rather than going through links that are not part of the domain. In addition to that, we improve the crawler so that it avoids any links that leads to images, PDF or JavaScript files. To avoid duplication of URLs stored in the memory, we use a hash set. This way, we made sure that we were efficient at using the available resources at our disposal. To crawl through the URLs and convert them to text files, we used an open source Java library called JSoup. This was an important tool for our search engine as it allowed us to strip the HTML tags from the HTML page and store them in a plain text. A method called jsoup.connect allowed us to visit the URLs and parse through the contents. It loads the HTML page and builds corresponding DOM tree. This tree works the same way as DOM in a browser, offering methods similar to jQuery and vanilla JavaScript to select, traverse, and manipulate HTML and to add or remove contents. Now let's talk about the Boyer-Moore search algorithm. To search for a pattern in the converted text file, we used Boyer-Moore algorithm. The reason we chose this is because it is considered to be the most efficient string matching algorithm to search through a text editor. It works the fastest when searching for a pattern in a relatively long string of text. One interesting feature of Boyer-Moore algorithm is that it scans the character of pattern from right to left, beginning with the rightmost character. Boyer-Moore algorithm is a combination of the following two approaches. They are bad character heuristic and good suffix heuristic. Each of them is used independently to search the pattern. Now, what is a bad character heuristic? A character in the text that has no match with the pattern is called a bad character. Now, when there is a case of mismatch, we shift the pattern until it becomes a match, and the pattern moves past the mismatched character. The bad character heuristic does not always provide good suggestions. The Boyer-Moore algorithm also uses good suffix heuristic to shift the pattern over the text string to find out the location of the matched patterns. Good suffix heuristic is based on matched suffix. Here we shift the pattern to the right in such a way that the matched suffix subpattern is aligned with another occurrence of the same suffix in the pattern. The worst case of the Boyer-Moore algorithm is order of mn, where m is the length of the substring and n is the length of the string.
Thank you, Roxy. Now we'll talk about inverted index. An inverted index is an index data structure storing a mapping from content such as words or numbers to its locations in a document or a set of documents. In simple words, it is a hash map like data structure that directs you from a word to a document or a web page. The primary reason behind using this inverted index algorithm in our project is that it has very fast searching performance. When user enters his input or a query, this algorithm would retrieve the list of documents in which that particular word is present. Once we get the list of documents, thereafter we can use another algorithm to extract the occurrences. This inverted index algorithm uses tokenization, and search engine condenses the words to their basic meaning, lowering the amount of resources required to store and retrieve data. Coming to the Java regular expression. A regular expression is a sequence of characters that forms a search pattern. When you search for data in a text, you can use this search pattern to describe what you are searching for. A regex can be a single character or a more complicated term. As per the documentation, it's an API to define a pattern for searching or manipulating strings. In our project, we have used it to remove special characters when we fetch the data from the web. We have also used it to make sure the URL entered by user is a valid one. And now my colleague Sarab would continue.
Thanks, Rahul. Sorting implementation. In our project, we have implemented sorting using collection.sort method, which is inbuilt method in Java collections library. We have used sort method to sort the results present in a specified list of collection in the descending order and then printed the results. Internally, collection.sort uses the merge sort for sorting, which is fast and stable and guaranteed to run in analog n time. Moving on to the next slide. We have implemented edit distance functionality in our project. The edit distance algorithm measures the minimum number of operations like insertion, deletion, or replacement required to convert one string to another. Edit distance has application in document comparison, spell checking, and computational biology. Now, Aksa will talk about the spell checker.
In our project, we have implemented the spell checker functionality. From the name itself, we can understand it will check the spelling is right or not. Along with it, it will suggest an alternative words as well. So there are two conditions with the spell checker module. If the user is inputting the correct word, it will give no suggestion and it will continue to the next step. But in case if the user is inputting an incorrect word, it will call the edit distance module and it will compare it with the list of words and suggest the best word possible. So that is the spell checker module. Now let's look into the flowchart of a web search engine. We will start our step here where the web search engine will take an URL from the user. Then we will have to check if the URL is valid or not using Java regex, which Rahul has explained is nothing but an API to define patterns for searching or manipulating strings. If the URL is not valid, it will request the user for another URL. But if it is valid, the web crawler module is implemented where it is optimized to get and traverse the subdomain link within the first URL. So after getting URL and the subdomain links, we have to convert those into text files using JSON, which is a Java open source library. And these converted files are stored in the internal storage. Then a keyword is requested from the user and the spelling of that keyword is checked with the spell checker, and it is done by searching with the internal storage and the data stored in it. And if there is a match found, then we will sort that and show results to the user. But if there is no match, edit distance module is implemented and they will suggest a word to the user. Along with that, we will show the results to the user and the suggested word itself. And this is the flowchart of the web search engine. In the next slide, Rahul will show the demonstration of our working project.
As you can see on the left hand side, here is our project structure. We are using Java 8. We have one main package called final project. Inside that package, we have 6 different Java class files, each having different functionality. Let me walk you through the code. This is our main class in which the main method resides. Once the execution starts, you'll be able to see these two options wherein user can enter the URL and start crawling and then doing the search. The control goes to the crawler.java wherein we crawl the website which user has entered. We have some validations like we do not want media files like JPG, JavaScript, JPG or PDFs. So this is the validation part. The second method is page link. So in this page links method, we have href tags in all the HTML pages, right? So this particular method fetch the href, the link from that page to another page in the manner of breadth first search. Coming to the third method, get page contents. This method basically stores the HTML data in the form of text in the folder called converted text files, which will be later on used to retrieve the search results. Once the crawler functionality is completed, the control goes to the inverted index.java. Here, as you can see, we have initialized 2 different maps, one for the string, one for the file and another for the inverted index in which the documents would be stored. The index building method would create an inverted index, and in the rows the document we can fetch the documents, and in the columns we have the keywords. Once the index building is completed, then we have find method. This method would return the list of documents in which the particular word resides. So when the user does the search, he would enter some query, and this find method would return the list of documents in which that query resides. Now coming to the third functionality, that is edit distance. Now when the user enters incorrect spelling, we would give him some suggestions. Now, as per the logic of edit distance, we are keeping the distance 1 as of now. In this way, our web search engine would take the suggested word and show up the results. Coming back to the web search engine, when we get the results, we call the word count method. Now, word count method is nothing but a Boyamo algorithm which gives us the number of occurrences that particular word has in that file. And that's the reason we are taking file name and the keyword in the parameter so that we can get the occurrences in that particular file. And later on, we'll sort them in descending order. Coming to the sorting part, we have created a list which is named results, RES, sorry. We are adding new results. Now, results is a separate class. This class has 4 class members, keyword, occurrences, path, and URL. And we are overriding the toString method too. The reason to create this class is because we want to sort the occurrences. Now, this class sort by occurrences implements comparator with the type of results, which was the class which we just seen earlier. We take the compare method and we return the results in a descending order. So that's why we are subtracting b dot occurrences from a dot occurrences. We can change it if we want to show the results in ascending order. So all the files are covered. Let me walk you through the code execution. So we'll enter 1. Now we'll enter the valid URL. For the demonstration purpose, we have kept the depth of crawling up to 25 pages. We can increase it if we want, but this is just for testing purpose, so you can see the results. Once the crawling is completed, then the inverted index would take its place. The index would create the building block internally, and now we are ready to search the words. So as you can see, we had many files in our local storage. So let me type billionaire. So as you can see, it says, did you mean billionaire? I had spelled it incorrectly, so it gave me the suggestion. It took about 17 seconds to fetch the results. These are the files. This is with the occurrence of 21. As you can see, the list is in descending order, which means the pages with the most number of occurrences would pop up first. And we are done with the demonstration part here. To conclude, we were able to create a functional web search engine with all the different concepts which we had learned in Advanced Computing Concepts class. We have successfully implemented features like web crawling, HTML to text conversion using JSON library, inverted index, spell checking with edit distance, and sorting algorithms. As you can see from the project demonstration, the results were accurate. The relevance and the performance of an online search engine are established by the accuracy of the results it provides. Now, despite the fact that our search engine is modest, it employs numerous algorithms that are functional and may be utilized for local file management. And now from here, Roxy would talk about the feature scope.
Thanks, Rahul, for the wonderful demonstration. Before we end this presentation, I would like to talk about the future prospect of our project. The future of web search engine includes providing better information filtering, techniques to find dynamic pages which are created on demand, web UI integration with dynamic database, a more efficient search engine that caches previously searched URLs. These are the references that we have used for our presentation. That is all, ladies and gentlemen. I hope you liked our work. Thank you.